Welcome to our YouTube lesson on metals. In our previous lesson, we looked at metals, and on extraction we started with the extraction of sodium. We then went to the extraction of aluminium. We also did extraction of iron. We also did the extraction of zinc. And in our today's lesson, we shall be looking at the extraction of lead and also the extraction of copper. If you didn't watch the previous lesson, ensure that you do so that you are able to connect with this topic. Our lesson today begins with a rhetoric question. Did you know that over 80% of all the lead that is produced ends up in lead acid batteries? There is a picture here of the lead acid batteries that you could have interacted them at any given point. Solar energy is mostly stored by use of these lead acid batteries. They're the same batteries that we use in our vehicles, motorcycles, and many other uses. Lead ores are as follows. We have galena, which is basically lead sulfide, and this is basically the chief ore. We have cerussite, which is basically lead carbonate, and we also have the anglesite, which is lead sulfate. Extraction involves three main steps. The first step is concentration of the ore by froth flotation. We have roasting of the ore to get the lead oxide. Then the lead oxide is reduced and finally purified. And by that, you have your lead metal. We look at the first step, roasting of galena. Galena, like we have mentioned, is the ore, the chief ore of lead. And like you can see, it's basically lead sulfide. It is roasted in air where it combines with the oxygen to form lead oxide and sulfur 4 oxide. This lead 2 oxide is then mixed with coke and limestone, and the mixture is heated in a blast furnace where the oxide is reduced to lead metal. These are equations for the process. The lead oxide, the one that we have, reacts with carbon. The carbon now is the coke, which a reaction takes place, and we have lead and carbon 4 oxide as the gas. Iron is then added to reduce any remaining lead oxide, and these equations take place. We have lead reacting with the lead sulfide, iron reacting with the lead sulfide to give us iron sulfide and lead metal, and this is what we want. Remember that iron is higher in the reactivity series than lead, and therefore it can displace lead from its sulfide. The calcium oxide combines with silica to form calcium silicate, and you might need to ask yourself where calcium oxide is coming from. Remember, when we decompose by heating the calcium carbonate, it gives us calcium oxide and carbon 4 oxide. So the source of calcium oxide in our equation here is from the limestone, which is calcium carbonate. Reacts now with the impurity calcium with the silicate to form calcium silicate, which by which we are able to get now our impurity out. The iron 3 sulfide together with calcium silicate combine together to form a slag, which is removed separately from lead. And by so doing, we have lead metal. Lead obtained this way is not pure, and a more pure lead is obtained through electrolysis. And how is the electrolysis done? We have the solution containing lead ions. It could be lead oxide. We pass current, and we have 2 electrons where the anode is made of impure lead, while the cathode is made of pure lead. What happens during electrolysis? At the anode, remember that the anode is the lead dissolves in form of ions and migrates to the cathode. So our impure lead, the lead that is pure, dissolves into the solution, and because the cathode is negatively charged, the lead ions are attracted or migrate towards the cathode. And upon reaching the cathode, they are now reduced. The lead dissolves to form lead ions which now migrate to the cathode. And let's now see what happens at the cathode. The lead ions from the anode now, upon reaching the cathode, they gain 2 electrons. And then lead metal is deposited at our cathode. By so, we have electrolyzed lead solution, and in this case we have the formation of lead sulfide, which is a bit pure compared to the one that is obtained from blast furnace. Uses of lead, I will send you to check with your notes to look at the uses of lead. We look at the next metal, which is copper. Copper is widely used in the mains electricity, as it is used in the making of electrical wires and contacts in switches, plugs, and sockets. And this is because copper is a good conductor of electricity. Pure copper is necessary for this use because impurities increase electrical resistance, and that is not what you want. So the copper ores that we have, the first one is the pyrite, which is basically the chief ore of copper. We also have the cuprate. We have what you call the chalcosite, and then we have the malachite. And you can see the formulas of those ores from the screen. The ores of copper may contain gold and silver as impurities. So in extraction of copper, the following stages are considered. The first one is concentration of the ore by froth rotation. We also have the roasting process in limited air. And this is the stoichiometric equation for the reaction, whereby we have what we call the pyrite, which is the ore of copper, being roasted in oxygen to give us iron oxide, copper sulfide, and sulfur 4 oxide gas. The copper 1 sulfide and iron oxide can mix, but when sufficient silica is added, a separate iron 2 silicate, which is now a slag layer, is formed. And we say that adding of silica also reduces the melting point of the ore. So in this case now we have what we call the iron silicate, which is a slag, which now separates out. Now we are left with the copper 1 sulfide, which is converted to copper 1 oxide by basically heating in regulated air. And this is the equation for the reaction. You can see that we have copper sulfide reacting with 3 moles of oxygen to give us 2 moles of copper 1 oxide, and sulfur 4 oxide. Now, this copper 1 oxide reacts with the remaining copper 1 sulfide to give us copper liquid and sulfur 4 oxide. And the copper obtained in this way is called blister copper and is usually 98% pure. It can be refined using electrolysis as follows. We have impure copper, which is now made our anode, and then we have pure copper as our cathode. And then now this solution is the one that contains copper 2 sulfate solution. During electrolysis, the impure copper goes into the solution as copper ions, while copper metal is deposited on the pure copper cathode. The equations for the 2 electrons is as follows. We have at the anode, copper, which is impure, dissolves into the solution to give us copper ions. And these copper ions now migrate to the cathode, where they are reduced by gaining 2 electrons to copper metal. By this case, we have pure copper. Uses of copper, I also send you to your notes and research on them. Mention at least 5 are good to go. Uses of copper. This is the end of our lesson. The references are KLB Chemistry Book 4, Longhorn Chemistry Book 4, and Chemistry for the Scientists. Subscribe to the channel so that you don't miss other videos when they are uploaded. Thank you.